In this section, we're going to be looking at the properties of parallel lines. To start off with, we're going to look at a postulate. Here we have the corresponding angles postulate. If a transversal intersects two parallel lines, then corresponding angles are congruent. So here we can see that line L is parallel to line M, and then we have the transversal intersecting both lines. So corresponding angles are congruent. So we see that we have a set of 4 angles on line L and a set of 4 angles on line M. So if we match up the positions, such as like 1 and 5 are congruent. Angles 2 and 6 are congruent because they're in the corresponding spots, so they're corresponding angles. Angles 4 and 8 are congruent, and angles 3 and 7 are congruent. The next concept we're going to look at is a theorem, the alternate interior angles theorem. If a transversal intersects two parallel lines, then alternate interior angles are congruent. So here we can see again that we have line L is parallel to line M, and then we have the transversal intersecting the two lines. And because it says alternate interior angles theorem, we're going to look at the interior angles, which are 4, 3, 5, and 6. And then alternate interior, so we can see that 4 and 6 are on opposite sides of the line, so they are alternate, and they are therefore congruent to each other. And 5 and 3 are alternate and interior, so they are congruent to each other also. And make sure that line L and M is parallel to each other in order for the alternate interior angle theorem to work. The next theorem we're going to look at is the same side interior angles theorem. If a transversal intersects two parallel lines, then same side interior angles are supplementary. So first we're going to see that we have line L is parallel to line M, and then we have the transversal that's intersecting. And because the theorem says same side interior, we're going to look at the interior angles again, which are 4, 3, 5, and 6, and this time the same side interior. So 4 and 5 we can see are on the left side of the transversal. Therefore, when we add 4 and 5, measure of angle 4 plus measure of angle 5 equals 180. And now if we did the same with the angles on the right side of the transversal, measure of angle 3 plus measure of angle 6 equals 180. The final theorem we're going to look at for this section is called the alternate exterior angles theorem. If a transversal intersects two parallel lines, then alternate exterior angles are congruent. So let's look at our diagram here. We have line L is parallel to line M, and then we can see that we have a transversal intersecting the two lines again. And because the title of the theorem is alternate exterior, we're going to look at the exterior angles, which are 1, 2, 8, and 7. And alternate, so 1 and 7 are on alternate sides of the transversal. So 1 and 7 are going to be congruent, and angle 8 and angle 2 are going to be congruent also. Keep in mind that all of these theorems and postulates only work when line L and M are parallel to each other. Now we're going to look at an example of identifying congruent angles using our postulates and theorems that we've just learned. So here in our diagram we can see that angle 3 is replaced by 55 degrees. So we know that angle 3 is going to equal 55 degrees, and we want to find which other angles measure for 55 degrees. So measure of angle 7 also equals 55 degrees by the corresponding angles postulate, which means corresponding spots have the same angle degrees. Now measure of angle 2 also equals 55 degrees by the vertical angles theorem. Measure of angle 3 and 2 are vertical angles, so they are going to be congruent and therefore have the same degree. Measure of angle 6 equals 55 degrees also by the corresponding angles postulate, because angle 2, which equals angle 3, is a corresponding angle with angle 6. Now we're going to look at another example. This is a proof of theorem 3.1, alternate interior angles theorem. So we're going to have to write a proof. So here the given information is that line L and M are parallel, and we have to prove that angle 4 is congruent to angle 6. So to start off with, the first statement is going to be line L is parallel to line M, and that is the reason is that it's given. Then angle 2 is congruent to angle 6. If lines are parallel, then corresponding angles are congruent. That's Now the next statement is going to be angle 4 is congruent to angle 2, and the reason for this is the vertical angles are congruent. Now that we've proved that angle 2 is congruent to angle 6, and angle 2 is also congruent to angle 4, we can use the transitive property of congruence to say that angle 4 is congruent to angle 6. And this proves the alternate interior angles theorem using a proof.